So the thing about being a good coder is that like we have to be able to tap into the code that is actually written by people that actually know more than we do. So you never want to reinvent the wheel in programming, and a lot of the code that we need to tap into to do a lot of the things that we need to do has already been written for us. So being a good developer in a lot of ways is actually how to assemble tools, how to learn quickly, and how to actually know which tools to use, which just comes with experience. And unfortunately, you can't really fast track that. But you could do a lot of blogging, as far as reading blogs or vlogs, following my channel, things like that, like to try to keep up to date with everything. But it's going to be impossible. You'll find that it's impossible to keep up with everything. And just experience over time, you accumulate way more than you thought possible, but it's just a timing thing. So let's go ahead and look at how we can actually use somebody else's code, like an actual library. We're going to create a new file, and we're just going to call it, we'll just call it module imports.py. So if we want to install something that we can use from other people's code sources, we can go to the command line. And it doesn't matter where you are in the command line, but I can say pip install request-html. Now this is a project that was written by the Python request people, but it actually has JavaScript support and all kinds of different stuff. So if you ever tried to reach across the web to grab HTML or like scrape a web page for some data or something like that, this is a great tool to use, and we're going to see how to use it in just a second. So we need to go ahead and import it, and to do that from Python, you need to say from, and then what it is that you're actually requesting, and then you're going to say import the actual thing that you want to use. So like the request HTML is the module library, and then from that module library, we're trying to get one piece of it, which is called HTML session, and then we're going to use that session object. Really the session class that we're importing to new up an object that we're going to call session. And just to let you know that we can see what type of object it is, we're going to go ahead and say print session. And before let's actually go ahead and see what the output is if we try to print the session to the screen. And we'll see whether or not we can even do that actually. So you can see that you get there's some sort of session object, and this is the actual object stamped out in memory. This is like where in the memory location you could find this object that is called HTML session. If I wanted to say the type, I could do the same thing, just print the type of it. And you can see that it is a class. It tells you it's some sort of class called request HTML.html session. So again, you're importing just a class on this HTML module. You're newing up an object from that class. And this is all object-oriented programming in Python. And then we want to go ahead and new up another object, which is really going to be a string variable that we're going to call session.get. Actually, this may not be a string. But now I want to do the session.get. I can go ahead and just give an HTML page. I'm going to give a page to a website that I own, so that way I don't get in any trouble for like sending a bunch of traffic to somebody else's website. So now if I wanted to go ahead and tell me what, I'm going to go ahead and just print the value of R. So you can get this response 200. So in HTML or HTTP, actually, which is Hypertext Transfer Protocol, the responses that you get back, like 200 is a good response, 404 is page not found. A lot of people are familiar with that, but this is what you're going to get back by default. So you could actually say if R, if you're checking for a response of 200, but let's go ahead and just print something else out. And if you wanted to, you could say dot, and you get this text highlighting, this text helping. So if I wanted to get the actual text of the page and print that out to the screen, I'm actually going to get much more data coming back. And you can see I actually get the HTML. It's all formatted properly for me and everything. But it's the HTML homepage of my website. You can see all that stuff in there. It's a really ugly website at the moment, but it's always under active development. I don't really do anything with it anymore. But that's the story behind that. But if I wanted to say, you know what, I'm not interested in all that text. I just want all the links on the page, because I'm going to go ahead and I want to see how many links there are. And I'm gonna like maybe scrape all the links and start following those links, because like we could do all kinds of crazy stuff. So here's our output. So you can see it doesn't find any links on the page, but that's because we didn't reference it right. The thing we need to do is we need to say, you know what, instead of all that text, which is HTML, I want to say, you know what, get me the HTML and then get me the links. This is going to use a built-in library. I believe this is using Beautiful Soup. I'm not 100% sure, but I think it's using Beautiful Soup. But now when I run this, because I said HTML, it's going to parse through all the HTML looking for any sort of links that it can find. Now, most likely because it's using Beautiful Soup, that's why it's really slow. But now if we look at the debug console, you can see the only thing that we're getting is we're getting anything on the page that are links. So you can see that we have these full spelled out links, and then we have these relative links. But those are all the links on the home page. So I could actually like assign those out to something like a list type. And a list type we haven't seen too much of, but we'll say my list of links equals. In Python, you use these square brackets. So if I wanted to actually say, you know what, I'm going to assign all those links to my list of links, I'm going to say, instead of assigning it to an empty list, I'm actually going to assign it to this value. And then we can go ahead and we can print this, my list of links. So the value type that gets returned here is actually a little bit unique. One of the reasons why, if we look at, if we hover over it, you can see that it returns a type of set. So set is very similar to a list in Python. And we're going to talk about all three of these different types all in one video here. My list is, you use square brackets, right? If you want to add an element to my list, I can simply say my list.append. Inside of these parentheses, I can just say string value. That's fine. I'm going to append a string value, just a string that has this name. In fact, let's just make it a little bit more interesting. I'll just say it has my name. And now if I want to go ahead and print my list, I can go ahead and do that. So another really common, really important thing I want to show you guys is that I can set breakpoints on my program using Visual Studio Code so that I can inspect certain things like my list. So if I say print type of my list, I mean, I can put breakpoints wherever I want and I can stop the execution. So if I press play now, I'll actually hit my code here, and like you can see it gives you all kinds of information on these variables, and we talked about all these different variables that we have, and you can look at like my list of links is this variable, and you can see, okay, what is it? If I highlight over it, it looks very similar to a list. Again, it's unfortunately this doesn't actually tell you. You can change its value, but it doesn't unfortunately tell you what it is, I don't think. Yeah, anyway. The point is you can find all kinds of information. Here's our R object, so you can see all the information that we have available to that. So we could say, if we wanted to go from one page to the next, you can see that there's this cookie jar in there. There's all kinds of stuff in there that we can interact with. And here's our HTML, so you can see all that HTML code that we printed out to the screen. There's our HTML. Here's our links. Here's LXML. So if we wanted to parse through using actual XML syntax, we can scrape the web using that. There's certain JavaScript and things that we can inject onto this object. So there's a ton of code written around all this that we didn't have to write. And the point is that using the right tools for the job is like half the battle. So I want to keep going down. If I want to go to the next line of code, you can see I have these different options where I can step over, step into, step out of. So I'm just going to go ahead and F10 to go to the next line. And now you can see that if we look over here, we have this my list, and it's an empty list of values. And lists in Python actually keep their order. So that's one of the main reasons why you'd want to use a list. Lists are also very flexible. So lists in Python are types that can they can hold an infinite number of like strings or numbers. They can hold other lists. So you can have lists that hold lists that hold lists inside of them. So you can have very complicated like tree data structures using lists, and you can actually take values in and out of them. So They're more memory intensive because you can do that. Now sets actually cannot have duplicates, so they're very similar to a list. That's why this my list of links looks very similar to some sort of array or list. But if there were duplicates in here, it would not allow them to go in. So that's the big difference. So if you don't care about duplicates, another thing is too, this is just automatically ordered. So it's just ordered based on whatever sort of internal settings are within Python. So you can't order this in any sort of way. So if order matters, you cannot use a set. Another thing that I want to talk about with lists is that you can also have something called my tuple in Python, and you see these sometimes too, and this is also very similar to a list, but these values can never be changed. So the big difference is that once you declare a tuple, it's basically read-only, it's a constant, the values cannot be they cannot be pulled out of or like anything like that. And once they're set, they're set. So like 1, 2, 3, and I'm gonna go and just break this here. And now I can even dynamically add the code, which is even crazier. But the program will freak out at that point, so you have to rerun it. So let's go ahead and do that. So now if we look over here, we can see that my tuple is very similar, as these two values, or I'm sorry, 3 values, and also looks very similar to something like a list, which looks like that. And then you also have a set. Now again, sets can't have duplicates, lists can. Tuples are much more memory efficient, just because if the values are never going to change, then the tuple is immutable. Immutable means that it cannot be mutated after you've created it. And if you want to type Visual Studio, you can see things like my tuple dot. You can see that there is no there's nothing in here that indicates that you can do anything to change the structure of it, like add a new value or anything like that. You can get the count if you wanted to, and so you're probably asking which one should you use, and for the most part, until you really know what you're doing, you probably just want to go ahead and use lists for any sort of data structure where you're trying to have a bunch of values. So I could actually assign this this list to so my list is a list type. So I could actually say my list now equals my list of links, which is a type of set, but I can actually force it to be a list by saying, you know what, make yourself a list. And then I can get the values from the set, and then I have my list is now a list of links, plus now Chris is going to be inside of it because we've appended a value to my list. So let's look at my list, and you can see once again, this is now a list type. And we can actually say, if we hover over it, let's see. Yeah, unfortunately, it's just giving me the values. I keep thinking it's going to give me the types, but it's not. That kind of sucks. Anyway, all right, so my list is a list, but you can see Chris is now at the bottom of this. So we grabbed all the links, and we have Chris. So why is a list important? Well, it's very important because I'm going to stop this program. I'm going to show you what we can do is we can say, you know what, I'm going to have a huge string, and we're going to call it huge string equals, we'll just say it's an empty string for right now. Sorry, my cold's killing me, sorry. So now I have this huge string, and what I want to do is I want to iterate over the list of values that we have in my list. So I'm going to say for item in my list, and then make sure I have a colon, and then this is going to automatically indent to the proper indentation that Python expects. And for every item in our list, and remember there's like 15 values or so, we're going to say, you know what, I want you to try to turn the R object to that value. And we could say huge string equals huge string, which is the current value of it, plus R dot, we'll say text. So now every time we go through our list, we're actually making the shared huge string variable. We're going to make it bigger for every page that we try to get. Now, the thing is some of those pages that we're going to try to get, we need to go ahead and say, you know what, I want you to go ahead and get the item and not this hard-coded value. and then it's going to append it to this huge string. So let's go ahead and run it. And in a for statement, I want to put a breakpoint here because I want to show you that for every item in the list, so here's our first value, it's going to go through every item in the list, and it's going to run this request session.get. So now we have this. Now huge string is right now empty, but if I go ahead and I play it, I'm just going to tell it to continue. You're going to see that we get to the next URL and it blows up. But before, if we could have done that, we could have actually seen the huge string. So it's actually a value that is not working. So I want to show you the error message that is actually going on down here. It actually tells you that the built-in library is actually saying it doesn't have like an HTTP or HTTPS or something like that, and that's what it calls the no schema supplied. So it tells you, like, you gave this relative path, but we have no idea what the relative path is. So now our program gets a little bit more complicated. So in the next video, I'm going to show you about logical operators that we need to start looking into.